Here we're going to look at the product rule for differentiation, which you won't be surprised to learn you use when you've got one function multiplied by another function. So say one of the functions is u and the other function is v. The rule that we're going to use, and it's proved in a different video, but you just need to know the result really, is you take the first function u and you multiply it by the differential of the second function. So u times dv by dx, and then you take the second function v and you multiply it by the differential of the first function, v times du by dx. Okay, so that's the rule. It is given in the formula book, but I imagine you'll probably know it quite soon. You'll be using it so often. Okay, so let's have a look at an example. So we're going to look at this one, y equals x squared plus multiplied by 1 plus 2x. So we're going to call x squared is going to be the function u, and 1 plus 2x is going to be the function v. So underneath here I'm going to write what du by dx is. So that's 2x, and dv by dx here is just going to be 2. Okay, so to come over on this side, and we'll write what dy by dx is. Randomly use my blue pen, but doesn't really matter. So we've got u times dv by dx, so that's x squared times 2, so we'll write 2x squared. And then v times du by dx, so that's going to be 2x times 1 plus 2x. That's how I wrote the v times du by dx. Okay, so we could take out a factor of 2x, and then inside would have, first term is 2x multiplied by x, and the second term is 2x multiplied by 1 plus 2x. So we can simplify that to 2x times 3x plus 1. Okay, let's try another. So let's make this equal to u and 2x minus 1 equal to v. So du by dx is going to be 2 lots of x plus 1. I've used the chain rule there, but it's a very simple case. If you want to write it out with t's, you can do, but basically it's just 2 times 2 lots of the brackets multiplied by the differential of the brackets, which is just 1 in that case. And then similarly, this one we've got dv, oh, we don't need to use the chain rule here, it's just 2. Okay, so dy by dx is going to be u, x plus 1 squared, multiplied by dv by dx, which is just 2, I'll put that at the front, and then v, 2x minus 1, multiplied by du by dx, I'll put the 2 at the front, and the x plus 1 here. So again, if we've got any factors, yes we have, we could take out a 2, and we could take out an x plus 1, okay, because x plus 1 appears in both terms. So multiplying that, we've got another x plus 1 from the first term, because it was x plus 1 squared, and on the second term we've got the 2, we've got the x plus 1, so we just need to add in the 2x minus 1. Okay, so we've got 2 lots of x plus 1, and then we've got x plus 2x, so we've got 3x, and then the 1's cancel out, so we could write that as 6x times x plus 1. Okay, so we've got one with a trig function in it this time, so let's make u x squared. Doesn't matter obviously which way round you do them, because multiplication is commutative, so it doesn't matter which order. So we've got du by dx here is 2x, and dv by dx is going to be minus the sine of 3x multiplied by the differential of the bit that's in the brackets, which is just 3. So we've got minus 3 sine 3x, again using the chain rule there. Okay, so using our product rule, dy by dx is u times dv by dx, so that's x squared times minus 3 sine 3x, plus v times du by dx, that's cos 3x, multiplied by 2x. Okay, what can we take out there? Not much actually, we could take an x out, I suppose. And I'll turn the terms around so we don't have the minus at the beginning. So we've taken out an x, so we've got 2 cos 3x from what was our second term, minus Now we've taken out one of the x's from that term, so we still need another, minus 3x sine 3x. Okay, can't simplify any further. Okay, now we've got quite a big question here, so I've left it big to be able to read it. So we've got the differential of a function, and we're told the form it's in, and we just need to find out what a and b are. I wouldn't say that's that easy, but anyway, we'll get there quite quickly. And then we've got to find the coordinates of the stationary points, so that's obviously where dy by dx is equal to 0. And then we've got to find the equation for a point where the curve crosses the y-axis. So all of these things, apart from the product rule, are things that you've done in C2 anyway, so they shouldn't be too challenging. Let's just make the question a bit smaller, so we've got room to do some working. Okay, so let's start off with y equals x plus 1 cubed, 2x minus 1 to the power of 4. So we're going to obviously use our product rule, so we're going to make x plus 1 cubed, u, and 2x minus 1 to the 4 is going to be v. So we're going to have to use the chain rule on each of these terms in order to be able to differentiate them. If you want to pause the video and just have a go at working out what du by dx and dv by dx are, that'll be a good bit of practice of your chain rule, but if not, just continue on. So du by dx is going to be 3 lots of x plus 1 squared, okay, multiplied by the differential of x plus 1, which is just 1. dv by dx is going to be 4 lots of 2x minus 1 cubed, multiplied by the differential of the bit inside the brackets, which is 2. So we've got there 8 lots of 2x minus 1 cubed. Okay. All right, make those a little bit smaller. Okay, so dy by dx is u, which is x plus 1 cubed, multiplied by dv by dx, which is 8 lots of 2x minus 1 cubed, and then v, which is 2x minus 1 to the power of 4, multiplied by du by dx, which is 3 lots of x plus 1 squared. Okay, if we look at the question, we know that we're going to have a factor of x plus 1 squared and 2x minus 1 cubed. And if we look at our two terms, yep, we've got an x plus 1 squared there and a 2x minus 1 cubed. And we've got 2x minus 1 to the power of 4, so we could take out a 2x minus 1 cubed and an x plus 1 squared, so it's looking good. Okay, so let's take out those two factors. So we've got x plus 1 squared, 2x minus 1 cubed. So from the first term, right, we've taken out x plus 1 cubed, but we've still got another x plus 1. Sorry, we've taken out x plus 1 squared. Let's just make that absolutely clear. Squared. So we've got another x plus 1 from the first term, and indeed we've also got an 8, so that's a bit bad. I'll put my 8 at the end, not very nice, but anyway. And we've got 2x minus 1 cubed. Okay, from the second term, we've got 2x minus 1 to the power of 4. We've taken out 3 lots of that bracket, so we've got to add on another one, so 2x minus 1. And we've got to multiply that one by 3, because we had a 3 here, and we've already taken out the x plus 1 squared. Okay, so tidying that up a little bit, we've got x plus 1 squared, 2x minus 1 cubed, and that's all multiplied by 8x plus 8 plus 6x minus 3, multiplying out my brackets. Okay, so we've got, I don't want to make that a bit smaller actually, I think. It doesn't want to. Okay, so I'll just move it up a little bit. Okay, so I have x plus 1 squared, 2x minus 1 cubed, 8x plus 6x is 14x, and plus 8 minus 3 is plus 5. So comparing with what we were looking at here, A is 14 and B is 5. Okay, so we've solved the first part, we found A and B. Okay, so the next thing we need to do is find the coordinates of the stationary points. So we know at stationary points, sorry, getting my pen to work. Right, at stationary points, we know that dy by dx is equal to 0. So we've got our dy by dx down here. So either x plus 1 squared must be equal to 0, in which case x is minus 1, or 2x minus 1 cubed is equal to 0, so x must be equal to a half, or 14x plus 5 is equal to 0, in which case x is minus 5 over 14. Okay, so we've got three stationary points at x is minus 1, x is a half, and x is minus 5 over 14. Okay, there's quite a lot on this screen. Okay, so last part, we need to find the equation of the point where the curve crosses the y-axis. So the curve will cross the y-axis when x equals 0. So we need to go back to our original equation here. Okay, so the y value will be 0 plus 1 cubed, which is 1, times 2 times 0 minus 1 to the power of 4. That all just comes to 1. The gradient we need to know, so we need to use our dy by dx here. So dy by dx is, when x is 0, is 0 plus 1 squared, 2 lots of 0 minus 1 cubed, and 14 lots of 0 plus 5. Okay. So that all comes to minus 5. So nearly done. Ooh, they're attached, never mind. Okay, so we've got value of x is 0, value of y is 1, and the gradient is minus 5. So we've got minus 5 lots of x minus 0 is y minus 1. So y plus 5x equals 1.